Node Audio was established in 2019 by myself and our co-director Ashley May. Ashley and I have run a successful industrial design consultancy for 20 years, designing products for a number of established brands. However, in 2019, we realised we wanted to develop our own product. The design consultancy was established in London. However, in 2013, we had the opportunity to move the business up to a Cambridge facility. The Cambridge facility is very much an innovation hub, focused on design and engineering, and has access to some incredible facilities. Our joint knowledge of additive manufacturing processes from our experience in the design industry led us to think about how we could reimagine loudspeaker design.
And we thought, okay, really, the vast majority of products are veneered wooden boxes, which have their place. But is that really relevant in modern hi-fi? And so we set about researching a product that would leverage additive manufacturing, industrial 3D printing, to open up new opportunities in acoustic design.
We approached an acoustic engineer who's well established in the industry with a concept. Halfway through, he stopped us and said, "You've got something pretty special there." From that point on, it gave us the confidence to put time and investment into developing our first product.
So we set out with Helixir to create a product that kind of transcended time, and in many ways it aesthetically looks like it could have landed in the 1960s or perhaps been from 2060. Based on the research of Olsen in terms of a product that created a really holographic soundstage. Of course, we know that a small sphere is the ideal acoustic shape, and trying to create a product with an effective single point source. But of course, when you do that, you do compromise the bandwidth of the product. And so that led us to think about how do we win back some of that performance. And by using additive manufacturing, we were able to package a transmission line, coil it up inside the head to then allow the speaker to have really great bass extension, but also that wonderful high frequency and holographic imaging that you'd associate with a small rounded single driver speaker. So traditionally, you might have a speaker built from flat sheets of material, which might have a path that goes through 90 or 180 degrees inside the speaker. With additive, we're able to coil a low impedance line within the speaker. But the key to this is we can then drive that line from two places. So in Helixir, we're able to suppress the resonant peak of the line because we can drive the line from 2 points. And that's our difference.
So the core of the design of Elixir is shaped around a helical transmission line, which led to the form of the egg-shaped speaker, which also has a lot of acoustic benefits due to its profiling. There are no hard edges in Helixir. Every profile is curved or radiused for acoustic benefits. The stand is part of the design. However, we also used additive process in the stand design and also in the crossover. Wherever there was a functional benefit, we used those processes.
Elixir is a three-way speaker, so we have the internal woofer that drives the line, but also on the front baffle we have two drivers, so a BMR driver, which covers the whole vocal range of the speaker, coupled with a small super tweeter, and they're positioned in really close proximity along with the bass driver, so we're creating an effective single point source, but with wide bandwidth. So Helix's cabinet is printed using a process called SLS, selective laser sintering. So it starts life as fine powder of glass nylon particles in a large industrial scale 3D printer. We feed that printer the 3D CAD file, and a laser will come along and fuse those particles together, grow the cabinet layer by layer. And it means that all of this complex geometry inside the cabinet is fused as one part. So there's no fixings, it's all a homogeneous piece. By double curving all of the surfaces, we can take out mass. So we don't use heavy bracing or thick walls because all of the walls are double curved. So by design, they don't want to store energy. The BMR driver, or balance mode radiator, is a really interesting technology. So at lower frequencies, it operates pistonically, and then it harnesses breakup modes within the panel to create a bending wave motion to play into the higher frequencies. So effectively, it means we can put the crossover to the bass driver down at, say, 200 Hertz and to the tweeter at 5 kilohertz, and most of the vocal region is captured by a single driver, so you don't get smear in the time domain that you would otherwise have through a crossover. So we've chosen a small super tweeter for the speaker, which is a ring radiator design, so it has really great off-axis performance, It's small in size, so we can position the acoustic centers really close to the BMR and the woofer to again create that effective single point source. So Helixir has some really interesting hidden details as well. We mount the baffle to the rear of the woofer in Helixir. There are hidden channels so that when the pole piece of the woofer vents, it vents into small helical channels which also couple with the output of the transmission line. And it's those small details that really make a difference that customers never see or really know about. Another detail is on the front of the speaker, we have a fascia plate which pushes on, and that hides all bolts and mechanical fixings, so that again you have a very smooth surface for sound to propagate, reducing micro diffraction that you would otherwise have. All of these details sum up to create a better sound and a more beautiful product.
We really want people to understand and appreciate the level of detail that goes into the manufacturing of our speakers, and the clever details that aren't always seen, but are housed by something beautiful in appearance.